Names and formulas for molecular compounds. The rules for naming molecular compounds that have covalent bonds and writing their formulas are very much the same in some ways as the rules for naming ionic compounds. There's some things that are similar. The main difference is when naming molecular compounds is the number of atoms of each element are included in the name. So the first thing, as far as rules are concerned, the first element in the name and formula of a binary molecular compound is usually the one that is farthest to the left on the periodic table. In the compound carbon monoxide, carbon comes first because carbon is to the left of oxygen on the periodic table. This is the difference from ionic compounds, whereas the name of the metal goes first for them. Number two, when naming, the suffix IDE is attached to the name of the second element. This is the same as with ionic compounds, right? So this is similar. So oxygen is changed to oxide in the name carbon monoxide. Prefixes are used to indicate how many atoms are present in molecules of the compound. The prefix mono means 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9, and deca is 10. The prefix mono is used only for the second element in the name, where there is no prefix mono is implied, as in carbon monoxide. Also, when mono comes before oxide, and an O is dropped. Thus, you write monoxide, not monoxide. Okay, so just remember, we only put mono for the first name. We don't put mono for the first name. Okay, if it comes singly, we only put it for the second name. The name for the compound that results from one carbon atom bonding with one oxygen atom is, carbon is furthest to the left on the periodic table, so it comes first in the name. The name for oxygen changes to oxide. There is only one carbon, so no prefix is needed. There is only one oxide, so the prefix used is mono. And the compound is named carbon monoxide. What is the name for NO2? Nitrogen comes furthest to the left in the periodic table, so nitrogen comes first. Oxygen changes to oxide, comes second. There's only one nitrogen, so there's no prefix needed. There are two oxygen atoms, so the prefix di needs to be used, and so we call it nitrogen dioxide. Okay, so NO2 is nitrogen dioxide. What is the formula for dinitrogen tetraoxide? The symbol for nitrogen is N. The prefix di indicates that there are two atoms. The symbol for oxide is O. The prefix tetra indicates that there are 4 oxide atoms. And so remember, we're not using the crossover method here. That's only used for ionic compounds. Remember that what the name is tells you how many there are, okay? So N2O4 is the formula for dinitrogen tetraoxide. Lime is a common name for a hugely important chemical with a broad variety of uses, including farming, the pulp and paper industry, and the food industry. The formula for lime is CaO, and its name is calcium oxide. You can figure out what it's made of and the ratio of atoms by using the name and formula. The common name doesn't tell you anything about the chemical makeup of the substance. The international system for naming chemicals is maintained by the International Union of Pure and Applied Science, Pure and Applied Chemistry, or the IUPAC. The IUPAC has developed a systematic method to name chemicals according to their composition. Scientists all over the world use the IUPAC. This system ensures that each pure substance has a unique name, called its systematic name. The name of a substance describes its composition. It also enables scientists to write its chemical formula and predict some of its properties. One important group of compounds breaks the naming rules we've learned so far, and that's hydrogen. Hydrogen, remember, is a nonmetal. Okay, so HCl is a molecular compound, but it's not named in the same way as other molecular compounds. Like other binary hydrogen-containing compounds, it is named as though it were an ionic compound. Remember that hydrogen acts like a metal, even though it's not. The correct name for HCl is hydrogen chloride, not hydrogen monochloride. So just remember that, okay? When we're dealing with sometimes hydrogen, we'll do this. Compounds containing hydrogen and carbon, such as ethane, which is C2H6, or ethanol, which is C2H5OH, have yet another set of naming rules, which you will encounter if you continue to study chemistry in grade 11, not in this course. So now, knowing what you know, and if you have to go back and review it, that's fine. I want you to test yourself and write the formulas for the following compounds. So you're going to write the binary formula here. Okay, for sulfur tetrafluoride, disulfur difluoride, dinitrogen trioxide, oxygen difluoride, nitrogen tribromide, and diiodine hexachloride. So test yourself on this. You're also going to test yourself on this. Okay, write the names of the following molecular compounds. So now you're going to take the binary version right here, and you're going to write it out in its name form. Okay, so Pi3, SO2, SO3, S2F10, CCl4, N2O5. So take that piece of paper, write it on there, okay? And I want you to pause the video, and then after you can check your answers. So here are the answers. So you can take a moment to check them to make sure that you got them. Remember that if you have any questions as you're going through this, as questions arise, make sure to write them down so that in class, when I do the review, you can ask me those questions.